So, hi, hello, welcome to my session on distributed transactions. Hopefully you can hear me all well. I'm surprised how many people I have. This is like the biggest room that I ever had. So please bear with me if I will make some mistakes. Shortly about myself, my name is Martin Stefanko. I work at Red Hat as software engineer, mostly on middleware technologies like Quarkus, Whitefly, and all the projects which are included in these runtimes. This is losing. That's not three. Am I picked up? Okay. I am also a microprofile committer. No, this doesn't work. Test. Okay. I am also a microprofile committer. How many of you are familiar with microprofile specifications? That's not a lot. That doesn't matter. Basically, Java EE or Jakarta EE now? No one. Come on. How many of you are Spring developers? How many of you use Spring Data? And you are not familiar with Java EE? Okay. You can find me on Twitter under handle xstefank if you want to see like the stuff that I'm like working about. Okay, so what we are going to talk about today is called Saga. How many of you heard about Saga pattern? That's way more about, that's nice. It's getting better now. Okay, for those that haven't heard about Saga before, I will go shortly comparing traditional ACID transactions to the Saga. So for my demo today and all my speaking, I will use a simple trip example where we need to book a flight, hotel, and car inside of one transaction. So we want all three or none of them. Yeah, one thing that I forgot to mention, please ask questions as I'm going because I forgot a lot and you usually remind me of things that I need to talk about. Also, the person who will be asking the most and not from Red Hat will get this very stylish fedora. So if you want to win fedora. Okay, so just shortly, what is ACID? Atomicity, basically all or nothing property. We want everything in the transaction to happen or nothing. Consistency, we will always leave the state of our system in a consistent state. Isolation, if we have multiple transactions being executed in parallel, we cannot make, or each individual transaction cannot see other transactions. So we need to basically act as they will be isolated. So like for transaction A, transaction B, either looks like if it wasn't started yet or it's already finished. And that's nice. Okay, what happened? Okay, this doesn't happen on my computer. This is your computer. Durability, basically we need to make our results persistent. Okay, so how do we do this is through something which we call consensus protocols. You probably heard about 2PC because it's being taught in most universities, but there are more of them. However, they are solving some of the issues of 2PC, but they still have that same fundamental error that I'm going to describe on 2PC because it's the simplest one. So if I put my transaction into 2PC, in 2PC we have a thing which we call 2PC coordinator, which is coordinating the transaction. Since this is talk about distributed transactions, imagine all of these rectangles as separate services over the network. So all arrows are network calls. So we will pass the transaction somehow to the coordinator, so coordinator know what the transaction consists of. In the first phase, coordinator requests the individual resources in individual services. We will locate these resources, and then we will do this nice thing we will log them, basically. So nobody else can access this particular flight seat, hotel room, etc. Now we can respond back to the coordinator that we are prepared, and this is the end of the phase one. If all of the services respond that they were able to prepare their individual resources for the transaction to commit, coordinator responds with a commit message to all individual services. Now we can unlock individual resources, actually commit them. So now we actually go ahead and pay the money for the flight, for the room, for the car. And if everything was successful, the transaction is successful. If in the phase one, some of the services wasn't able to allocate, there are no more cars, we basically say that we are aborting the transaction. So coordinator sends the abort message. again, we will now just remove the logs on the individual resources. We will forget about them, and we will respond everything failed. We can try again. What is the issue with this, and especially in the network? After the first phase, if all of the services respond with a prepared message, what happens if the coordinator dies? Because this is distributed. This will happen. You might have more requests for the same resource coming from different sources. So if this is the last place in a flight, you might have like 4 other people in the meantime wanted to pay money for that flight seat, but you are still locking it for some transaction which is unable to finish. So this is where Saga comes in, and this is the problem that Saga tries to solve. Saga pattern actually isn't something new. Actually, the paper that introduced Saga pattern was published in 1987, and it described basically long-running transaction only in a single database environment. But still, the same concept applies today. So what is Saga different, or where the Saga differs, is basically in a way how we basically handle the failure cases in a transaction. So in Saga pattern, you need to define something which we call compensations or compensating actions. Basically, you can imagine this as a business undone of the original action that you are performing in the transaction. So if your basically transaction action is to insert something into a database, the simple undone or business undone is to remove something from a database, surely. However, your action might be something which is changing the world. In other words, it's not idempotent. So for instance, if you send an email as a part of the transaction, you cannot unsend email. However, this is a business compensation. That means that you can send a follow-up email that will say that previous action is canceled or something similar. The important part is that compensating action is something that you as a business developer define. It's your compensating action. So either it's cancel order, cancel the reservation, whatever, it's up to you what it happens. So the same example, but this time in Saga. So in Saga, we will start simple. So we are just passing our Saga directly to the first service that is going to participate in a transaction. It will allocate the resource in the same way as 2PC did, but this time we are not taking any logs. We directly go ahead and we will pay money for the seat. So now we are already breaking acid because we are now in inconsistent state. We have booked the flight, but not yet car and hotel. So basically, with this paying for the flight seat, we are basically done at airline service, and we will pass the Saga down the chain. So in a hotel, we do the same, allocate the room, pay for the room, to the rental, same, find the car, pay for the car. If everything was successfully booked, now we are already consistent. We can respond back that whole Saga is successful. But what happens if something cannot be booked? So again, car, there are no more cars in a car rental service. So now we are already in a state where we paid money of our customer for the flight, for the hotel, but we are not able to finish the whole trip. So in Saga pattern, we go in a reverse order of the services originally called, and we will basically send a cancel Saga message back, which basically only means that hotel service knows that it needs to invoke that compensating action, which in our case is just refund the credit card that paid for the hotel room. And the same thing in flight. Go ahead. We will get to this. It depends like how you orchestrate. Oh, should I repeat questions for the recording? No? So it depends how you are orchestrating your microservices. So either it is defined in some external service like coordinator, we will get to it, or if you have like really chain microservices that you need to know like what needs to be called back, or basically you don't need to. It depends how you implement this, because the compensating action needs to be somehow defined. You need to somehow specify it. So you will just receive some JSON cancel Saga, and airline service can have the logic to find out, like, I know that I need to call this method with these parameters. Go ahead. Oh, this is not our problem. we are doing transaction. Saga itself will never finish until all the services respond. So we will get to it in a later that this can like run for days. Like we are not giving like upper limit for how long this can run. Basically, that calls from hotel service to current. Wait a second. Are basically your individual microservices call. So you should have some fault tolerance inside your microservices call to handle these cases. This is outside our scope. Go ahead. There was one other question. There is not yet any coordinator. Give me a second. Go ahead. This is the difference in the Saga. Here you are not taking any logs, you directly pay the money. Go ahead. Good question. This is up to the framework to handle. In our case, I will show you how this is handled when we will get to it. Okay, so moving on. Again, transaction was fail, so we need to retry in the future. Okay, so I have this just one more time, that failure scenarios to like show that individual actions if it isn't clear from that original one. So like really now that inner rectangles are actions that we are invoking. So we are booking the flight, then we are booking the hotel, then we try to book car. This is not possible. So we are going back the chain and invoke another action inside the same service, cancel hotel and cancel flight. Okay, so I already talked about ACID, and I already told you that Saga isn't ACID anymore because we are in inconsistent intermediate states. So they came up with a new acronym, which is still chemistry valid, which is called BASE. So yeah, of course, we are losing isolation because two Sagas executed in parallel can see that Saga A has already booked flight and not booked anything else. And we are also losing consistency because every time we are in the intermediate state of the Saga, we are in inconsistent state because our consistent state is defined by the transaction. So Saga came up with the acronym BASE, which stands for basically available. This means that I was told that this is not totally correct what I'm going to say, but I still need to read the book. If you are familiar with CAP theorem, in distributed systems, you need to choose if you value more consistency or availability of your services. So in Saga, we are more focusing on that availability, so we are not stuck with locks somewhere and we have other calls blocked. And in ACID, we are more consistent. Soft state is basically still the same thing. That means that if you, in any time, look at the state of your system, it is not really, you cannot say that it's consistent. Saga defines something, which is the last bullet in BASE, which is called eventual consistency. What this means is that if you stop executing any new Sagas in a system, eventually, in some point of time, you will get into consistent system. This is what we guarantee. Okay, so there are two ways how you can implement this. The first one is decentralization. That was the first example that I saw, that the Saga is like a self-living thing, which is passed between your chain of invocations. Or you can have an orchestration where you again have something which is called Saga coordinator, which is basically coordinating Saga in a similar way as 2PC, but not totally, not the same protocol, not in the same way. So Saga can be again passed either to the coordinator itself or to the individual services, and services now must enlist within the coordinator, so coordinator knows how to invoke them back. So each service enlists with the coordinator, and then coordinator basically knows when there is time to either invoke compensation or something else on each service, coordinator knows what to invoke. And in this way, there was a question how to handle if compensation fails. If coordinator now, because the implementation that I am going to show you uses coordinator, if coordinator sees that the compensation failed, we will try to call it again in the future until you are able to respond, because otherwise we are not able to finish the transaction. Unless, of course, you can define heuristics if you want. So after some time out, you can like say, okay, I don't know what happened. Some person please come and look. What do you mean consistency cannot be reached?
Let's say that we
You will be retrying until you will be able to call. You have that eventual consistency. That means that we are expecting that that third service will come up eventually.
But what if the third service will not be able to do that?
This is that idea of eventual consistency. Eventual doesn't mean that it needs to end, basically. We are not giving you like any upper bound.
But we are assuming that it will be reached at some point of time, right?
Yes, you can also define a timeout which will basically say like, screw this. Basically, we don't know what happened, we don't want to wait anymore, but eventual consistency is really, you need to write your code with this in mind, that this can take days or even more. Okay, so the implementation that I'm going to show you now is called microprofile LRA, which is short for long-running actions, which is basically transformation of the Saga pattern into Java specification. This is already released in version 2.0. Basically, you can find it on GitHub as all microprofile specifications, and the implementation that we are developing in Red Hat is in Narayana project, which is our transactional manager. Okay, so I think, now fingers crossed, okay, this works. So I will be coding a lot, so please, again, ask questions as I'm going, because I will definitely forget something. So for my framework of choice, of course, you know that I am at Red Hat, so I will use Quarkus. This is how you create Quarkus application. You will get also a nice intro to Quarkus today. So I have already now Quarkus service, so I will open it in my IDE. And I can start the dev mode, I think, right away. Oh, sorry. I'm used to my aliases. QD is Quarkus dev. OK, so how do I make this presentation mode? OK. So what this generates for us is a simple Maven project. It's not that important to get into details. One important thing that I want to show you is this concept of extensions. So each functionality in Quarkus is basically a separate Maven module, which we call extensions, which contains some logic that Quarkus requires, like build time, runtime principles, GraalVM compilation, etc. So since version 2.8, I think Quarkus switched to different implementation of JAX-RS, which is called REST Easy Reactive, which has a slight bug, which doesn't work with LRA. And it's already merged, but it didn't make it to the last release, which was yesterday. So you need to wait 1 week for this fix. So for this reason, I need to change back to the REST Easy Classic. So how you can do that? Basically, you can manually manipulate the POM XML to remove dependencies at dependencies if you know what they are. However, I want to play that I don't know, because I don't know. With Quarkus extension, I think you can list all the extension. Like Quarkus is a CLI that you can install or download from the internet. It doesn't matter. The same commands are available with Maven Quarkus plugin or with Gradle build task. Quarkus CLI is just like wrapper around this, so it doesn't matter which build tool I am using in the background. So with Quarkus extension, I can list all the installed extensions that I have in my application. With Quarkus, X is short for extension remove. I can remove extension. And now check the left terminal. You saw that something happened. That was the live reload mode, and you can see that this manipulated my POM XML. I don't need this. And now I don't have that REST Easy reactive extension in my service. Even if I could have showed you that it is working before, but I didn't, so sorry about that. You will see that now I cannot call my method that I have exposed, but you need to believe me, it would work before I removed that extension. And now I can, if I can type, add all the extensions that are required for Narayana. So Narayana comes in, or LRA comes in Narayana LRA extension. Is this big enough for everybody? Okay. However, because Quarkus is providing multiple implementation of the REST protocol, we needed to make it work with both old REST Easy and the new REST Easy Reactive. So I need to manually specify that I want to use old REST Easy now and old REST Easy client. However, from version 2.10.1, you will just add Narayana LRA and it should work. Oh, okay. I didn't expect that I didn't have downloaded. There was a release yesterday. Hopefully I can download everything because I am on my internet. Sorry about this. I can switch to the old one, but yeah, it's fast enough. This is like always fun that they make a new release always on Wednesday, and I have always talk on Thursday. Okay, so hopefully if everything worked, I got a bunch of just Maven modules into my application. However, now I have that functionality in my application. Everything is automatically reloaded in the background. So if I try that HTTP call again, I will get back a response. However, now, where is it? I no longer have REST Easy Reactive, right? So I have REST Easy Classic. I will just save, repeat the call again. Magic happens, and now I got REST Easy Classic. So this is that live reload mode that I was talking about. If you come to the Red Hat booth, I can show you more about this. Okay, so usually this is more than enough to get you going. However, because Narayana LRA coordinator runs by default on port 8080, and I am running my service also on port 8080, this is one of the rare cases when you need to stop the dev mode because you want to run on different port. However, configuration properties usually are reloaded too. So I need to go into my configuration, which lists in resources application properties, and here I will put two properties. First one is that I want to run this application on port 8081, and the second one is the location of the LRA coordinator, which is still not yet running. However, I can fix it really easily because it's available in Docker container. So now, hopefully on port 8080, I should have the LRA coordinator running. Hopefully. Yeah. So with HTTP GET on path/LRA coordinator, coordinator returns all active LRAs that it knows about. So of course, I haven't started any yet, so I have empty JSON. However, I will put this into a watch so we can see if I start some, they should pop up in that lower terminal. Okay, and I will open one more terminal for my client. And I will start the dev mode again. Hopefully now I have everything ready and my application will now start on port 8081. Hopefully, yes, just a quick verification, 8081/hello, still responding. That's nice. Okay, so first thing, because I am writing a flight service, I will create a flight resource. I will make this Jaxares resource on flight. I will make a post method to create booking. Response, Jaxares response. And here I will do just a simple method to log nicely something so you can see it. I will say here booking flight. Then I will actually perform the booking, which I will define in a minute. And then I will just return response, okay, built. So for, oh, not F3. Shit. In this perfor booking, for now, what I will just do is basic thread sleep, so we have time to see it in that watch that the LRA was started. Okay, so now I have my booking action. And basically, to start LRA, when this method is called, and I will use LRA and Saga interchangeably, because this is what we call it in the specification. All you need to do is put @LRA annotation on it. However, this is not totally true, because each service that is communicating with the coordinator needs to define itself either as a participant, that means that it's participating in that Saga, and it defines that compensating action, or it needs to define itself only as a just listener for the end of the execution of the Saga, because otherwise, this is the unfortunate case. If you don't want to specify implementation details in specification, you need to sometimes make workaround that will force each implementation to verify that the LRA or the Saga is started actually when this method is invoked. So this was deliberate choice, which I didn't agree with, but here we are. So to make, I will make flight service, of course, a participant because it will participate in a transaction. All you need to do is define another method which coordinator can call. So I will make this now a put because it's more like update or changing the state. I will call it cancel. It can also return response. Here we will say canceling flight, and I don't need to do anything else here, just return okay build. And to define that this particular JAX-RS method is compensating action for this service, I need to put another annotation which is called compensate. So this should be hopefully everything. And if I have a coordinator running, now if I may HTTP post, no, HTTP post at 8081/flight/book. Hopefully, if I type everything correctly, we started a new Saga. And if you were able to see it in this terminal, I will do it again. For 2 seconds, we have a new LRA started inside that middle terminal, and after that, it's finished. However, you see that we are not printing that canceling message anywhere. And why is that? Because we are not canceling the Saga. We are finishing successfully. So to specify that you want to cancel the Saga, we basically fall back to the JAX-RS protocol. That means that if your JAX-RS method annotated with LRA fails, we will cancel the Saga. And this is defined by 2 parameters in that cancel, that LRA annotation. Hopefully you can see this, which is basically cancel on, where you can specify, specify individual status codes, HTTP status codes on which to cancel, when you will return from this method, we will cancel the Saga, or we default to cancel on family, which will cancel on every 400s or 500s status code, which is basically fail of JAX-RS. Go ahead with the question. I will get to it. So basically, to cancel now, all I need to do is copy paste this, and instead of OK, say here, if I can type status 500, for instance, if I just save this and repeat the same call, now I'm returning 500 from that call. What's happening? OK, slow computer. Sorry. So you see that we have our compensating action invoked because now the Saga failed at the end. So all the compensating actions of all the participants that have been enlisted in that Saga that was started in that one participating service are now compensated. There is also one other handler, so I will go back to the success state, which you can specify, which again will be a put method. I will say complete, which is basically one-to-one the same callback handler as compensation, but for the success state. And why this can be useful, because you can imagine, we will get to it, that you need to remember which particular resource corresponds to which particular Saga. So this is some state that you need to remember in your application. So this complete handler is useful to tell you that the Saga, generally Saga was finished, and you can just like forget this information because you know that the compensation handler will never be called again. So I will do just the same thing here, just saying completing, hopefully correctly, completing and return response, okay, build. And now if I will make a mistake, because I know that I make a mistake, so I will show you dev mode with mistake. Oh, I forgot semicolon. Good to know. So it won't break. Dev mode. Okay, so now after 2 seconds, and I don't have anything because, of course, I forgot to add annotation. You now need to also tell the implementation which JAX-RS method is the completion handler in this case. So hopefully now, if I repeat it, I will get completion handler called. At least you see that if you make as many mistakes as I do, you still can work with dev mode and you don't need to stop it. Okay, so the question was like how we can associate if we have multiple sagas in this class. So LRA specification defines that the implementation must pass in unique identification in form of URI inside the specific LRA HTTP context header, which is long dash running dash action. And this is URI, but oops, I just don't want to type everywhere two strings, so I will just use string here and call it LRA ID. And we can add LRA ID here. Oh, no, what did I do? Let me just copy paste this because I don't have that much time. And I can use this header also inside the compensation handler and also inside the completion handler. Basically, you can use it in every method that is invoked within the LRA. There are more annotations inside the specification. The protocol handles a lot of cases, which we will not be diving in 20 minutes into. Yes, well, try to like say the use case. You start the same saga inside this class.
Yeah, but on complete you might want to log that everything is success, right? So you might have 10 sagas and don't want to repeat this complete action each time. So you would like to just write it once.
So each participant is specified inside one JAX-RS resource. So you can reuse the same completion and compensation handler, but inside that one participant. If you create a new JAX-RS class, you need to create a new set of handlers. So you can see that we got that same unique URI that is passed to all the services, so you can associate this information within your resources. Okay, so if there are no more questions, okay. We don't have option for this in a specification, but in Narayana we have. So you can specify some, but it's like really only some things that we will store in a coordinator. So it's actually, I think, string only. And also, it's not really our responsibility to do, and I would dare to say not the correct microservices design. Okay, so this is surely nice, but it's only one service, and I promised you microservices. So I will do really quickly a new service by a really fast way. And I will just replace lowercase flight. Oh, shit. No. Did I do this in flight? Ooh, I was able to close it. Yes. Because I ran it in the parent directory, so it would rename also flight, which I didn't want to do. Okay. So hopefully now it works. Uppercase, and I will move the flight resource. No. Main. Oh, what is it? Java, iOS, Stefanko. Hotel service already. That is strange. So, oh, that's okay. Shite. Sorry, I got lost in my own computer. Okay, let's try to do this once more, and I hope that I didn't run it in the wrong directory. So let's try to do this once more, because of course that I will make such a silly mistake. So hopefully, fingers crossed that I didn't rename anything that I shouldn't rename. Flight hotel and move. Okay, now it works. So I will also Maven clean just to be sure. And hopefully, if I open this now in IDE, I have hotel service, that's good. And I have hotel resource, and just looking really fast. Okay, I have hotel, more or less. Hopefully, I didn't rename anything that I didn't want to rename. So if I now run it, oh, one more thing. I forgot that I need to change, now hotel service will be running on port 8082. Okay, so hopefully, please, demo gods. So hopefully now I have also a hotel service running on port 8082. Hopefully I don't need to show that it's also will start its own Saga when I call hotel/book now on 8082. So I want to propagate the Saga from flight service to the hotel service. So I will go back to the flight service. I will create my choice of REST client invocation or HTTP client invocation is microprofile REST client because it's easiest for me. So I will create a hotel client interface. If you are not familiar with microprofile REST client, you are basically typing an interface in the same way as you would type JAX-RS resource. So it will be looking almost exactly the same as my JAX-RS resource in hotel service. So this will be /hotel. Here I will have post at path/book. I don't really care what it returns. I will just call it book hotel. And one thing that you need to define in here is register REST client annotation. So Quarkus will recognize this is intended as REST client, not as a JAX-RS resource. And what is very useful, you can also specify hard-coded base URI in this, which is great for demos. So I know that my hotel service is running on localhost 8082. So just saving this in my flight resource, now I can inject this as a REST client, call it hotel client, and then JAX-RS invocation is just hotel client/book hotel. This is already going to be HTTP call to 82 port. So hopefully, if I have everything written correctly, if I now repeat call to the flight service in above, it should be restarted, and we got it propagated to the lower terminal in the hotel, and completion handlers have been called. It was called here in both services. Nothing so fancy. You see that we do some magic in the background, so we see that you are making outgoing call from your application on port 8081. We see that it's running inside Saga, inside LRA, so we propagate the context header for you, so you don't need to do it manually. However, you can manually specify it, because actually the magic happens inside that LRA HTTP context header. So if you specify that manually with some different LRA, this will be the LRA that the hotel service will try to enlist to. So by default, it's the active context, but you can override it if you want. This nice error that I'm getting here is that could not close LRA is because by default, now I'm back in hotel service, each LRA by default tries to end the LRA that is correctly being run inside the method. When this method is finished, it will basically send a signal to the coordinator that either complete or compensate depending on the outcome. This is the default behavior. However, if you specify here end false at hotel service, that means that the hotel service will not now send that ending message. If I just save this and run the post again, hopefully after 2 seconds, I will get the completion handlers called. However, this time we ended it correctly back in the flight service where we started it. So in this way, I get rid of that unnecessary message. Oh, okay. So any more questions?
I wonder if you were thinking about, because what you're showing is calling all these steps, let's say this booking and how it's all synchronous. I wonder if you were thinking about, sending the request on one server and receiving later.
I am showing you because I switched back to the REST Easy Classic. Then I am stuck with blocking JAX-RS calls. But however, there is nothing which in LRA protocol which would prohibit asynchronicity between your calls in the services. Because basically how this is happening is that when that flight service is calling hotel service, we will intercept that call. We will enlist hotel service within the same LRA in the coordinator, and only then we will invoke that hotel service book method.
But the LRA itself can start on one instance, and then another instance could be observing on the change, and it would complete on another instance, right?
An instance of coordinator?
Yes.
Yeah, so the coordinator is based on Narayana Transactional Manager, and there are actually several, they call it object stores, the place where you write the transactions. So there are several ways how you can configure these object stores. You can have several several instances accessing the same object store. So it should be possible. Go ahead.
What in case when you have resource that can be used in multiple other arrays, and maybe in one it should end this.
So that's a good question. You can have multiple at LRA methods inside that class. You can only have one compensation and competition handler. So you can have like a different use cases. So I can either like write at LRA and false in one method, and in second one and true. So I will have it running until I decide to call that second JAX-RS endpoint, which has and true. Okay, so if there are not any more questions, one more thing that I can show you is also, because this was requested in the specification, you can also specify a time limit inside this annotation. So I will set it just for the 1 second. So I know that our method or our Saga now runs for 2, but if I call it now again after 1 second, hopefully I will get the cancellation compensation code. However, this is, of course, distributed timing problems, so you cannot be like totally sure that this will be exactly in 1 second if you are not running on one laptop all the services. Of course, some timing issues can happen. Again, this is eventual consistency, so this means every time that we are trying to call that competitions or compensations, basically we are trying to do our best to like make the valid call. However, sometimes when coordinator will have a different time set on the machine where the coordinator is running, you can get into potential problems. So I wouldn't rely too much on this. However, there is this possibility. Okay, I still have 9 minutes left, so I'm thinking if I want to dive into something else. I was faster today. Sure, there is no more questions because usually I am like finished, not even like here. It doesn't really matter. Like the coordinator itself is a Docker service running here. So it's a separate service. Now I have 3 services running on my machine. Only flight service is starting now the Saga, but it could be like, you can imagine that I have a, actually I think that the demo that I have at the end of this presentation have this. I have a trip service which just starts the Saga and doesn't enlist as a participant. So it's only that after LRA listener. And then it will call the flight service as a first service in the transaction with the new LRA ID, and then it will call hotel, and then it will call car. So it depends on how you orchestrate your microservices. Go ahead. Yeah. When coordinator dies, when coordinator dies, there are retries inside the handlers, which should be able to handle these cases. However, I don't want to really go into this because I haven't prepared it, so I know that I will not do it correctly. However, if coordinator dies, because this is still eventual consistency, the client knows that it wasn't able to either enlist. Actually, I think that for the enlist, we will directly fail because otherwise we would be able to block your microservices call forever if the coordinator won't come up. But for that, for anything else, you are not actually calling the coordinator itself. So yeah. I will fix myself. For basically, the only case when you are calling from the client services, so from that flight and hotel, the coordinator is for the enlist. And if we would be blocking or retrying in that enlist, that means that we would be blocking that call from flight to hotel, potentially forever, with retries. So I think by default, we failed this. And we will like tell you to handle this with the status code in a flight service, so you can set up your own fault tolerance to do the retries on your strategies. However, from the other case, if the flight service dies and coordinator will try to call the compensation handler and it will get connection error, it will try to do this again in the future. There is a configuration in the coordinator itself which will do this periodically until it succeeds. You can also say from the compensation handler that you are not able to compensate right now, but you will be able in the future. So coordinator, again, will just like save like this flight service wasn't able to do this right now. I will try to ask again in the future. Go ahead. Yes, I always get this question, and yes, I would so unfortunately only REST now because my profile. However, in Narayana we are not restricted only to this. So I would like to see some form of connectors. If you are familiar with reactive messaging in microprofile, there is a form how you can, basically idea of connectors, where you can, through configuration, plug different protocols into the both, basically, in our case, would be coordinator and the client. Individual enlists can still be happening because there are two ways where we can plug this, either communication with the client and the coordinator, or the communication between the individual clients. Because now, unfortunately, this is implemented as JAX-RS filters, so it works with REST only. However, this is just bad design. We can write this as a normal interceptor, so we don't actually need to require that this needs to be a JAX-RS method. So this is something on our to-do that we need to tackle. Yes. That was already asked here. If you can configure multiple instances of the coordinator on top of the same object store, which is basically your database, which is storing the transactional data, everything should be accessed only through that object store. This is how, like, already even 2PC, if it's more 2PC coordinators accessing the same transactional log, works. Okay, so if there are not any more questions, I don't think that I want to dive in anything more in 3 minutes. So thank you for your attention, and talk to you.